Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from probability and statistics. This particular question belongs to paper 9709/53 for the session May June 24. Let's solve question number 6. And the question says, how many different arrangements are there of the 9 letters in the word recorders? Well, so the clue word of this question is different arrangements. And we all know that for arrangements, we simply apply the concepts of the permutation. So we can write number of arrangements. Number of arrangements is equal to total there are 9 letters. So it will be 9 factorial ways. After that, we must not forget to divide the number of factorial equivalent to the identical letters. Let's see how many letters are identical. Here, yes, this E, sorry, not E, R. First R, second R, third R. So there are three identical R's. So it will be divided by 3. And at the same time, there are 2 is as well. 2 is. So we will divide whole of the arrangement by the number of identical letters. So there are 3 R's. That's why we are going to divide by 3 factorial. As well as there are 2 is. That's why we will have to divide by 2 factorial ways. Now let's use calculator for finding this. 9 factorial over 3 factorial means 6, 2 factorial means 2. So 9 factorial over 12 is equal to 30,240 ways. So this is the answer to the first part of the solution. Then the immediate next question says, how many different arrangements are there of the 9 letters in the word recorders in which there is an E at the beginning, an E at the end, and the 3 R's are not all together. So this is the clue word of this question. Out of 2 ways, we will follow the simpler and easier way to solve this. And that way is, look, they have written all R's are not all together. That means R's are not all together. We will think in reversal way. We will find that what is the number of arrangements when all R's are together. So there are two restrictions. First restriction is there should be an E at the beginning. So let us start our writing. If A is an E is at the beginning, and then 2, 3, 4, 5, 6, 7, 8, and another E at the end. So we will find what is the total number of arrangement when an E is at the beginning and another E is at the end. So number of arrangements when an E at the an E at each end, at each end, at each end. Well, when the E's are an E at the each end, what will be the scenario? Look at this. Here there are total 9 out of 9 E's have already been fixed. So what are remaining there? There are 1, 2, 3, 4, 5, 6, 7. There are 7 factorial ways the remaining letters can interchange their position. So we will write 7 factorial ways. 7 factorial. Among them, 3 R's are identical. So we will divide them by 3 factorial ways. So total number of arrangement with this restriction is 7 factorial over 3 factorial, that is 840 ways it can be arranged. So this is the number of arrangements when an e at each of the ends and no other restrictions. And initially we have decided that when r's are not all together, that means we will think that when r's are together reversal ways. So let's see what is the number of arrangements when e's are at each end and r's are together. Okay, number of arrangement, let it be arranged over here. E, then 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 and 9. Ninth one is E. So R's are together. So 1 R, 2 R's and 3 R's. These 3 R's are together. They are now together as one unit. If these R's are considered to be one unit, then how many arrangements can happen? So we will write here number of arrangements when an e is at each end, at the same time all r's are together. at each end and r's are together. r's are together. Together. So what will be the number of arrangements when r's are together and an e at each end? So total number of arrangements is going to be, look at this, e's have already been fixed, so there is no question for arranging e. We will just arrange the remaining letters. So as all r's are behaving as one unit, so how many units are there? 1 2 3 1 1 2 2 3 4 5. 5 factorial ways they can be arranged. Well, so it is 5 factorial ways, and there is no question of identical letter because there is no identical letters except E and R, which have already been calculated. R's are already one unit, so there is no question to divide by any other identical number of letters. So 5 factorial means 120. Since we have gone through the question, we decided that we are thinking this from different viewpoint, means in reversal ways. They have told us to find when three r's are not all together. We have considered that all three r's are together, that means it's in reversal way. So how can we find the final arrangement? We will just subtract the when r's are together from the total number of arrangements. So let us write, hence hence number of required arrangements equal to, here also we could have used equal symbol, and here also equal symbol. Well, equal to, as we have decided, when an E is at each end, total number of arrangement was 840. From 840, we will subtract this 120 because this was the number of arrangement when all R's are together. So if we subtract all R's together, then definitely there will be no R together. So let us write its total was 840. So 840 minus 120, then it is going to be 720. So total number of arrangements for these two restrictions is 720. That is what the answer. Now you may ask a question that why did we do it in a reversal way, that why didn't we do it directly, that these three R's are not all together. In that case, you will have to undergo some complication, because they have told, look, the word is all R's are not, three R's are not all together. What does this mean? This indicates all three may not be together, but there are two R's can be together. So we'll have to find the number of arrangements for together, for two R's together, for no R together. Then all of them will have to be calculated. That's why this is the simple way. If we think the reversal way, first we find the number of total arrangement with E and each end, it is 840, from which we have subtracted the number of arrangements when R's are together. They're told to find R's are not all together. We have found when R's are all together. Then as this is reversal, from total number of arrangements means 840, we have subtracted the number of arrangements when R's are together. This is the simpler and easier way to solve this question. Then let's move on to question number C. Question number C says, the 9 letters of the word recorders are divided at random into two groups, a group of 5 letters and a group of 4 letters. Find the probability that the three R's are in the same group. So it's a very simple concept. And remember, as there is no question of arrangement, it is just simple selection. For selection we apply the concept of combination. It's no more permutation, because nowhere it is written that the letter should be arranged, just letter will be selected or picked up. Well, so what are the cases? They have told all three R's should be in the same group, and in the first group there will be 5 letters, and in the second group there will be 4 letters. 5 letters, and here 4 letters. Okay, let's assume that all three R's are in the first group. If R's are first group, so 1 R, 2 R's and 3 R's. So how many letters still to be chosen from the remaining one? 2 letters. And if 5 letters go away, there remains all 4, which should be chosen. Okay, then in the second case, let's see, none of the R is in the first group of 5 letters, so all the R's are in the second group of 4 letters, so one more letter is to be chosen. So how can we calculate them? I think I should have space in between them, so let it be just erased. Okay, leaving some space, I will write here, suppose there is no R in the first group, so all 5 letters should be chosen from the remaining one, and the R's will be in the second group of 4 letters. So if 3 R's are already chosen, so 2 more letters should be chosen from the remaining ones. Okay, we have already decided, as there is no question of arrangements, that is just selection or choice, so we will have to use the concept of combination. In total there are 9 letters. Out of 9, 3 R's have already been chosen, so we cannot choose any R anymore. How many letters are remaining there? If 3 R's are chosen, 6 R's are left, I mean 6 letters. So from 6, first we will choose 2. Well, then if 2 and 3, 5 letters have already been chosen, so there remains only 4 letters. Out of 4 we are going to choose 4. So finally it is going to be what? 6. If 6 letter, I mean 2 letters are chosen from 6, it is going to be 6 factorial over 6 factorial over 2 factorial as well as 4 factorial. Okay, and 4 factorial 4, I mean 4 choose 4. If you choose 4 numbers from out of 4 numbers, it is actually nothing but 1. Yet I can write it as 4 factorial over 4 factorial into 0 factorial. Okay, so finally what is the total number of selection here? It is going to be 6 factorial means 720, and 2 factorial means 2, 4 factorial means 24. So 24 twos are 48. If we divide 720 by 48, it is going to be 15. So there are 15 choices to choose 2 letters from 6 and 4 letters from 4. Well, let's see the next possibility. What is the next possible number of choices? Yes. So in the first case, look at this. None of all 5 letters should be chosen except these 3 R, because 3 R's belong to the group of 4 letters. So they cannot be at all in the letters of 5 group. So total there are remaining 6. We will write, we will choose 5 from 6, isn't it? 3 goes away, so there remains 6. Out of 6 we will choose 5. 6 choose 5 chosen from 6 into, here there are, sorry, it should be 4 letters, but by mistake I have written 5 spaces. Okay, now for the second group, 1 letter is to be chosen. Actually out of 9, all 8 over 5 letters has been chosen here, and 3 letters have been, 3 R's have been chosen. So 8 letters have already gone away. There remains only 1. So from 1 letter, if we choose 1, it is going to be actually 1. Okay, after that, if we calculate this, what is it going to be? 6 choose 5 equal to, we can write 6 factorial and 5 factorial, and if we subtract 5 from 6, it is 1 factorial into 1 choose 1 means actually simply 1. Yet if I show 1 factorial over 1 factorial or 0 factorial, 1 factorial, 0 factorial. Okay, now let's see. From 6 letters, if we 6 factorial means 720 and 5 factorial means 120, 1 factorial means 1. So if we divide 720 by 120, it is going to be 6. Okay, and 1 factorial means actually 1, so it's all the same one. And I think you have understood, if all r's are, if all r's are in the first group, then there remains only 2. These two should be chosen from remaining ones. That's why we have written 6 choose 2. And for 4 letters, there is no more specification. There remains already 3 R's and 2 letters. 5 have been chosen, so there remains 4. Out of 4, we will have to pick up also 4. So 4 choose 4, and ultimately we have got that there are 15 ways to select these two groups. Then in the second case, all 5 letters will be chosen from the remaining, but R, none of the r's can be chosen for the first group, because this case, in this case, second case, r's belong to the second group. So now if 3 r's goes away, there remains 6 remaining letter. Out of 6 we have chosen 5 for the first group. Out of 6 we have chosen 5, and in the second group there were how many? 4 letters. Okay, out of 4 letters, 3 r's have already been chosen, so there remains only 1. So out of 1 we are going to choose 1, that means in 1 ways. So ultimately we have got our first case, number of selection is 15, and in the second case, number of selection is 6. So total number of selection is, number of selection, number of selection is selection is equal to, first there are 15 ways and then 6 ways, so 21. That means in 21 different ways we can select the numbers according to this question. Well, now we should not get deviated from the fundamental question. The question told us not to find the number of selection. Look at this. The question told us to find the probability. Okay, so we will have to find the probability finally. Let's see what is the probability. Number of selection, number of total selection. That's why we'll have to specify this. Here we will have to erasing this number of required selection, not all selection, it is required selection. Number of selection with restriction, because here there was some restriction to be followed. Restriction is equal to, we have got that 50 plus 1 26, and number of total selection, number of total selection. Total selection is very simple, that total number of letters, so we know that there are total 9 letters, and out of 9 there will be two groups. In one group 5, first for 9, from 9 we will get, from 9 we will choose 5, then there remains only 4 letters. These 4 letters will be chosen from the for the next group. So what is it going to be from 9? If we choose, can I write just beside or below this? I think I can write just below this. So 9 choose 5 means 9 factorial over 4 factorial into 5 factorial into 5 factorial base into 4 choose 4 means actually 1. I have already explained in the previous part. Well, if we use our calculator to divide 9 factorial by 4 factorial into 5 factorial, it is total number of selection is going to be 126. 126. So this is total number of selection, and number of selection with restriction is what? 21. 21, and they have told us to find probability, so simply we will write the probability. Let us find the probability. If we divide the restricted one by total number, it will be our probability. Hence probability is equal to, not with this ink, let us write using the red ink. So probability is equal to probability equal to total number of selection is 126, and out of which 126, and total number of selections with restriction is 21. 21. So our probability is going to be, it is 1/6, means 1.666. If we round it up to three significant figure, it is going to be 1.67 is the probability, because please don't forget that they have told us to find the probability of this selection, not to find the selections finally. So that's all about the whole of the solution to question number 6. First two parts were based on permutation. This was about permutation, and we applied the concept of permutation for solving this. Whereas the second and final part of the solution was, the question was based on selection and no arrangement matters here. That's why we have just found different number of selections, and finally we found the probability, not the number of selections. So probability is simply the number of selection with restriction over number of total selections, and thus we have got that 1.67 is our final answer. So thank you all for being with me. Inshallah, in the next video we will solve some other questions. Fi amanillah.